Okay, and we are live. Hi, everyone. Thank you so much for joining us to another Virtual Jug session. Today, we're happy to have with us Stuart. Hi, Stuart.
Hi, how are you? Thanks for
We're,
having me on.
I mean, it's a pleasure to have you here on VJug all the time. So we're very happy to have you with us. And I believe that you're bringing us a new awesome topic to talk with us, which is the VAR coming on Java 11. Or actually, that's already out there, right?
Yeah, well, it's in Java 10, and
Oh,
so
10, exactly. Sorry
people,
about that.
yeah, as time goes on, I think we're all going to kind of lose track of the version numbers.
Oh, yeah.
But people are up. I suspect most people are skipping over 9 and 10 at this point and going straight to 11. So at a certain point, it's not going to matter which release it's in.
Yeah, I already lost track of it, to be honest. It's kind of like the Firefox and Chrome versions, right?
Yeah.
So anyway, Stuart is bringing us a session called VAR with Style, Local Variable Type Inference with Java in Java. It's going to be introducing about VAR, and I'm really hopeful that we're going to have a very awesome session. And I'm pretty sure that I think it's the first time that we're bringing this topic on the VJug, and I think it's awesome to have someone that's really experienced with that with us. So before we start, let me just add to our viewers, please, you can join us on our Slack channel. Go to the virtualjug.com website. You'll see a link over there. You can join us on the Slack channel, on the live session channel, and you're able to post live questions on our session, and I'll be happy to relay that to Stuart. So, Stuart, the screen is yours. Feel free to start whenever you want, and good luck.
All right. Okay, let me bring it up here. Okay, you see that?
Yep.
All right, very good, thank you. Okay, so as Roberto mentioned, this title of its talk is VAR with Style. The VAR is the sort of keyword that's used. The official name is Local Variable Type Inference. That's the official name of the feature. So I work at Oracle. I work on the JDK team at Oracle. I do a lot of work on OpenJDK in the core libraries, including collections and streams, Lambda, serialization, and deprecation. Mustn't forget that. And this is my Twitter handle and hashtag VAR with Style. I keep an eye on that hashtag when I'm doing this. Although since we have a Slack channel, if you're on Slack right now, then you can ask questions there, and I'll probably be interactive on Slack after the presentation. If you're watching this on the recording, then if you tweet to me or on that hashtag, then I'll be able to see the question there. Okay. All right. There's that. All right. So let's talk about VAR. So like I said, the official name is Local Variable Type Inference. And so that's a pretty descriptive name, right? So one is it applies to local variables only. And the other part of it is it's about type inference. And the idea is that you can ask the compiler to infer or to figure out the type for you instead of you having to declare the type explicitly. So that by itself, the official title, Local Variable Type Inference, is pretty descriptive. So let's have some details about what that is. So up until this point in Java, if you declared a variable, you'd have to give it an explicit type. So here's kind of a typical variable declaration in Java. Suppose you have a class customer with a capital C. So you can have a variable customer equals new customer. So you call its constructor, right? Pretty typical. And so what VAR lets you do, or what local variable type inference lets you do, is instead of declaring the type explicitly, you say VAR instead. Now, at this point, okay. So if you say VAR, then the compiler will say, let's see if we can figure out what the type of this variable is based on the right-hand side of the equal sign. So it does that. And so it figures out that the type is the class customer. Now, at this point, I want to say that Java is still statically typed. We're not making any fundamental changes to the type system of Java. This is a little more than syntactic sugar. I mean, it's not strictly syntactic sugar because it's not just syntax. The compiler is actually doing some work to figure out what the type is. But once the compiler figures out the type, it is almost as if you had written the type explicitly instead of typing var. So one of the things that it's a fairly frequently asked question, or an assumption, an incorrect assumption that people make, is that since we're using the keyword var, that Java is turning into JavaScript, and JavaScript is a dynamically typed language, and so people make that confusion that Java is also going to be dynamically typed, and that's not true. So again, Java is still statically typed, and the type is inferred and is established at compile time, like when you run Java-C. And if there are any errors that occur at that time, you get compile time errors. So this is still our good old friend static typing. And now, if you were hopeful that we could get rid of static typing, then your hopes are dashed. But for those of you who like static typing, and that's why you like Java, we are sticking with static types. Now, type inference is not new in Java. One of the things I've seen in several articles around the internet it's like Java is getting type inference. And it's true that this is a new feature that has existed in other languages already. It's a new feature in Java. Other statically typed languages like C# and Scala and Kotlin and maybe a couple others have had the ability to declare variables this way and have the compiler infer the type for you. So that aspect is new to Java. But the fact is that type inference has existed in Java already for quite a long time. There's a whole history of it, but I think the most prominent example is with lambda expressions. If you consider lambdas, the compiler would do a lot of type inference for the lambda parameters. And so you can write a lambda expression and not have to declare any types at all. And that's type inference of a different form, but it nonetheless is still type inference. Okay, so where can we use var? And so, like its title said, local variable type inference, it can be used only for local variables. And so that applies to variables that are declared within a method in kind of an ordinary way. Notably, though, it also applies to resource variables in a try with resources statement, as you can see in the example there. And it also applies to loop variables in the for each loop or in a conventional loop, conventional for loop for that matter. So those are all considered local variables. Now, there are a bunch of places where var cannot be used. In particular, it can't be used for method parameters, can't be used for method return types, and it can't be used for fields. And this is not it's not inherent to the concept of type inference. Certainly, this was a design decision. Certainly, it is possible in many circumstances for the compiler to perform type inference and on say a method parameter or return type or field or something like that. But it was an explicit decision by the people who designed this on the languages team at Oracle not to support type inference in these places. And so the reason is that unlike local variables, things like method parameters, return types, and class fields show up explicitly in the class files, and therefore they are part of the class's API. And so we felt that it was best to have source programs and programmers be explicit about what types end up in class files and therefore end up in APIs. And since they're in APIs and in the class file, this affects binary compatibility. And so you can, without too much effort, you can start to imagine how if you're editing a source file and something like a method return type were inferred, you might be editing the method body and accidentally change the return type of a method. if it's not if it were the case that the return type were not declared explicitly, if the return type were inferred, you might change the method body, and thereby the method return type might be inferred to be something different from what it was. Now, since that shows up in the class file, that might be an incompatible change to the class file, and your programs might break because of that. So there's a whole class of errors that can be introduced that way. And so we felt that was too dangerous to allow type inference for those pieces of a program. Okay, let's see. So now, if you write var, how does the compiler determine what type to infer? And so, like I said before, it looks on the right-hand side of the initializer of a declaration. And so if we say var customer equals new customer, so there's a class customer, and so clearly the type of the variable must be that class customer. Var name equals Terry. Okay, so that is a string literal, and its type is string, and so the type for name is inferred to be string. And var number equals list of 1, 2, 3. So that is inferred to be list of capital I integer. That's the boxed form of integer. So there's a little bit of auto boxing going on there, but otherwise that type is list of integer, and so the variable is inferred to have that type as well. So this is pretty straightforward, but notice there are a bunch of cases where this does not work. So if you just say var customer semicolon, that's illegal. That will cause an error at compile time. So you must have an initializer for a var declaration. All right, now suppose you say var customer equals null. That is also an error, and so that's actually a little subtle. There's a bunch of detail going on behind the scenes here about what null actually is. But I think the question is, if you assign something to null, what type do you want that to be? Well, it's hard to say. Kind of the only thing that you might consider could be object. And so we could have a rule that says, okay, if you initialize something to null, then its type is object. But if you look at actual programs, and if you declare a variable and initialize it to null, usually you're going to assign it to some other value. And it's quite rare that object is the actual type that you were interested in. So so we could, I think there's another design decision behind the scenes here. We could say that if you initialize something to null, then its type is object, but that doesn't seem that useful. So that seems it's more like a mistake. If you want to initialize something to null with the intention later on of assigning to something else, then maybe you should use an explicit type instead of using var. So we decided to declare that to be an error. All right, and then the last line on the slide shows an example of a lambda expression. And so one of the things about lambda expressions, I mentioned earlier that there's some type inference going on already in lambda expressions, and the primary issue with lambda expressions is that they must have a target type that is used to infer the types for the lambda expression. So the target type is the context in which the lambda expression occurs, and often that comes from an explicit type declaration. Now, if you say var on the left-hand side, then that's asking the compiler to infer that type. And so we have type inference attempting to go on both sides of the equal sign. And there's simply not enough information there for the compiler to determine what the type is. So we don't have enough type information to determine what the lambda is. And so since we don't know what the type of the lambda is, we don't know what the type of the variable being declared is. So basically we say you can't do this. You need to supply some more explicit information in some other fashion. So this line also, this last line on the slide also.
Okay, and what about if you use the anonymous in the class version of the lambda?
If you use an anonymous inner class, if you declare everything explicitly, that is, if you don't use diamond, then that will work, because the type of an anonymous inner class is well understood. Although there's a bit of an edge case there, because the type of an anonymous inner class is anonymous, and so it actually, I think the rule is it actually gets folded to the nearest the nearest named type. So that's not a very precise statement about what it is. So
Okay.
So that will probably work. We can try that out later if you're interested, but that's a bit too much detail for this.
Yeah, I mean, I was just curious
but it's a
because
good,
you were referencing Lambda, so I was wondering about the long version.
Right. No, fair enough. Lambda expressions require a lot more type inference machinery than anonymous inner classes. So if you really wanted to do something like this, you could probably declare it as an anonymous inner class, and it will probably end up doing something reasonable. And actually, I think Nikolai in a couple of weeks is going to dive into these kind of issues more and show you what you can do with it, which is, I think, mainly a curiosity rather than something inherently useful. But it is kind of fun. Okay.
Wonderful. Yeah. Sorry. Carry on.
No problem. All right. So I want to talk about the ability to reassign a variable that's been declared with var. So here's the first line. We have var name equals Terry, and so as before, the variable called name is inferred to have type string, and so it is mutable. You can reassign it. You can assign name to be Dana instead, and that is also a string. But you cannot reassign name to be some value of another type, like list of. That's compile time error. And so the type of the variable declared is established at the point of var. The compiler doesn't look all around your program and find a type that fits all of them. When you say var name equals Terry, the type of that variable is string, and then everything else again is type checked against that. Now, in this second example, in the middle of the slide, we have name list equals list of Robin, Kim, and so there, the type is inferred to be list of string. And so what you can do is you can assign that to be a new array list. And so array list is also a list of string. And notice you can use the diamond operator here because name list already has the type list of string. And so that's enough information for the diamond operator to say, oh, okay, he has an array list here, and array list is a list, so that's okay. And the diamond gets filled in with string, and so that's okay as well. Now, there are other languages that have a different syntax, like val or let, that declares a variable that cannot be reassigned. We decided not to provide those in Java, and so if you want a variable that cannot be reassigned, you have to use the final modifier. I don't want to go into too much detail about that. There's some fairly subtle reasoning behind that. That is in the FAQ, which I will reference later on in the talk. Or we can talk about it afterwards if people really want to know about the details of that. Okay, so let's take a look at a simple example here. We have a method create customer that returns a customer. So this is not a very interesting example, but we just declare a new variable and assign it to new customer. We read some stuff out of a buffered reader, and we get some purchase orders out of the customer and then return the customer. All right, so what happens when we try to use var here? That's what it looks like. So we replaced the explicit type declarations with var, and the compiler infers the type of those variables based on what's on the right-hand side. And that's pretty simple. So, okay, covered all the material I wanted in 20 minutes. So that's all there is, right? No, it wouldn't be an interesting feature without some controversy. And so, whenever you're reading something on the internet, somebody posts an article, they always say, don't read the comments. I have this compulsion. I have to go read the comments. And so when you read comments on example on articles about var in Java, you get a bunch of comments like this. I think some of these are based on misconceptions, like this one about JavaScript. Some of these are based on this fear of other people misusing language features. Of course, I will never misuse a language feature, but other people will, and that's why this is a bad feature. So you get those kind of reasonings and argument like that. And I think that's sort of, on the one hand, that's sort of unreasonable to say, you know, the language should not have a feature because somebody somewhere in the world might misuse it. On the other hand, if you sweep away the emotions surrounding that, notice all of these have exclamation points. For some reason, people get terribly angry about this. They say that Java is ruined by the addition of this feature, and frankly, I don't get that. However, I think there are some genuine concerns here, because I think there are many language features it is possible to misuse. And what does misuse mean? Suppose you wrote a program and then you decided to rewrite that program using a different language feature. Would the result be better or worse than the original one? The fact is, sometimes it's worse. And so if the program gets worse if you use, if you employ a feature, then you could say, oh, yeah, that's a misuse of that feature. The question is, when is it a good idea to use var, and when is it not a good idea to use var? And so that actually is the main point here, which is we need to have that discussion. We need to have those kinds of discussions about, this is a good place to use var because it makes the program better. This is not a good place to use var because it makes the program worse. And there are cases like that. And so that actually is what the rest of this this talk is about. All right, so let's move on here and think about why we add features to a programming language, right? We want to add features to a programming language to enable people to write better code. Now, how does this apply to var? So there are, there's a lot of history of of Java, people complaining about Java being a very verbose language. There's a lot of clutter. And so var can help that. And the fact is that whereas there are many cases where having explicit type declarations in Java is a good thing, there are places where the explicit type declaration is unimportant or it's redundant. And when you have a situation like that, then it's just clutter. And so var lets you get rid of that. And getting rid of clutter is one half of the equation. The other half of the equation is that it lets, if clutter is unimportant, you should get rid of it. But that also implies that there are things that are more important. For instance, the variable's name. And I have some examples of this, which I'll show. But you can argue that in many cases, variable's name is more important than its type. And so we would want the names to stand out more in those cases. There are other cases where if you have a long expression, say with chained methods, you might want to extract something into a variable. But writing out the type of that variable explicitly is so onerous that you might decide not to do it. Well, var eliminates that, that burden. And so you can extract a sub-expression into a local variable at much lower cost. But really, the bottom line here is readability. Does the program get better when you use var? And in many cases, it does. Now, one thing I should say, though, is that this is really about readability, not the idea that, hang on a sec. It's not the idea that, oh, okay, I'm typing a program at the keyboard and var lets me type fewer characters. So that way my fingers aren't going to get tired out. That's not really what the issue is, because that issue is usually, most people use IDEs, there's auto-completion, there's that sort of stuff. Really, the issue of var is when somebody is reading the program. And so that might be one of your colleagues who's reviewing it. That might be somebody 6 months from now or a year from now. who might be you or somebody else who is reading your program and trying to figure out what to do. When they read your program, or when you read your program in the future, when future you reads the program, you want to be able to understand as quickly as possible what that program is doing and what it's intended to do. And so if there's a lot of clutter from redundant type declarations, then that slows down readability. And so the argument here is that if you use var in certain places, you can improve the readability. And so that makes code easier to read and debug and maintain and so forth. All right, now maybe there are times that you shouldn't use var. So there's some clear cases, which we already discussed, like method parameters, return types, and fields, where var is disallowed. But are there cases where you shouldn't use var even though it actually is allowed? And so this gets to this idea of, it's like, you know, var is a bad feature because it enables people to write bad code. And if you're willing to buy into that line of reasoning, I have bad news for you, which is that people will write bad code regardless of what features are in the language. People have been writing bad code in Java without var for years. And the remedy for this is not to say, do not add this feature. The remedy for this is to teach programmers to write better code. And you know, I think we need to do that. Now with var, I think we need to teach people how to use var appropriately. And so that's what this talk and some of the documents I will point to later on are all about. In particular, I've written, with the help of some of my colleagues at Oracle, a set of style guidelines for the use of var. And so these distinguish good uses versus misuses of var, and how to distinguish, and you know, when to use them and when not. And so I have a bunch of examples of this in subsequent slides. The main issue is that, I think what we're trying to do here is that at the time we introduce a new language feature, we're trying to come out with materials such as style guidelines and FAQs that guide people in terms of how to use those appropriately. In the past, I think, notably with lambdas, we didn't produce any of that material, and so what happened is that people would, I mean, there was a bunch of randomness where people said, oh, should we use it here? Should we use it here? And there was a bunch of a lot of uncertainty about proper use of things. And so the fact is, in development of this feature internally on the languages team, there's a lot of discussion about, well, what happens if you use var here? Should we disallow that, or should we allow it? Should we allow it even though it's a bad idea? I think there are reasons in the language that you might allow something, but there are times when it's not a good idea to use it even though it's allowed. And so we had those discussions, and so a lot of those discussions got turned into the material in the style guidelines. All right, so this style guidelines document has been, actually, it's been up there for several months now. It's been posted on the OpenJDK website. You can see the URL there. That is still valid. I also have the link at the end of the slides in case, and it's also appeared on Twitter. But anyway, the link is on the slides, which I will post later on.
I'll post them right now.
Okay, great. Did you get that URL, Roberta?
Yeah, I'll just search it.
Yeah, it's not too hard to find. Okay, so this is the general outline of the style guidelines. There are 4 principles and 7 guidelines. I'm not going to go through them all. I think I'll just hit a few highlights. Otherwise, the presentation would just get too long. And some of them are fairly subtle and detailed, and frankly, not all that interesting. So, so off we go. All right, one of the things that seems to occur a lot in internet discussions is a straw man example. People will make up a bit of code and say, we're going to use var here, and look at this. This is terrible. We have no idea what's going on in this code because we now no longer know the type of variable x. And so You know, this is horrifying. This is unreadable. var should never have been added to the Java programming language. So this kind of example is used to justify that line of reasoning, and that is what I call a straw man argument, because the example is very bad to begin with. Somebody has a method called get something, and so I mean, let's think about that a little bit. What does get something do? Well, it gets something, but we have no idea what that is. And then we have a type named myClass. Well, presumably that's intended to be meaningful, but in fact, since this is a simple isolated example, it has no meaning. And so since you start off with an example, and then the variable name is x, well, what does x mean? Well, x has no meaning. I mean, it's sort of the generic free variable. So if you start off with an example like that and then say, let's substitute var and try to make some evaluation of this code based on the change to var, really, this example is not telling us anything. So instead, what we should do is take, oh, okay, so yeah, that's the problem with this example here. And in case you weren't aware, quelle horreur, I'm using sarcasm here, just to make that explicit. Okay, so let's use a better example. And this is something that you might see in actual code. Input stream equals socket.getInputStream. So we are pretty sure we know what this does. We have a socket, we're getting the input stream out of it, and we are storing it into a variable whose type is input stream, and the variable's name is input stream. So now let's substitute var for this. Okay, so have we lost anything by substituting the explicit type for var? So we're saying input stream only twice instead of 3 times. We lost anything? No. Have we gained anything? Yes. There's less redundancy. There's a little less clutter. It's a little more concise. And this is where some of the guidelines come in. In the style guide, one of the guidelines is choose variable names that provide useful information. So instead of x, we're saying, okay, we have an input stream. Well, maybe a reasonable name for that is input stream. Also notice and here's where we can have a useful discussion of the context. On the right-hand side of the initializer is an expression, socket.getInputStream. Well, we're pretty sure that socket is a socket of some sort. We're probably reading something off the network, and network sockets have an input stream. And now this requires some knowledge of the APIs, but if you do any network programming, this is pretty obvious. And so if you want to read some data off a socket, you need to get its input stream. So we're pretty sure we know exactly what this is doing, and getting the input stream out of a socket returns an input stream, and we're pretty sure we know that too. So really, the explicit type declaration is not adding anything. And so that's guideline 3, which is, hey, if you can look at the right-hand side and know exactly what's going on, then that is sufficient information for somebody to interpret the program, and so you don't necessarily need the explicit type anymore. All right, so let's expand this a little bit. So here's something. Is a try with resources statement that gets the input stream out of a socket, wraps an input stream reader around it in order to read characters, and then wraps a buffered reader around that. This is sort of the typical usage of the I/O libraries in Java. But notice what's going on here, right? Where we have to, prior to Java 10, we would have to have explicit type declarations everywhere. And so what this does is it makes the lines kind of long, and you have to put line breaks in, and it makes it a little hard to see what's going on. In particular, where are the variable names that we're using? And so these are all kind of mixed into the header portion of the try with resources statement. So now let's look at what happens when, okay. So on this slide, I've highlighted the variable names. So they're sort of buried in the middle between the explicit type declarations and the initializers on the right-hand side. Quick aside here, we do want to have explicit variable declarations here in try with resources, so that if an intermediate resource is it fails to open properly, then previous resources are closed properly by try with resources. So kind of the old style for doing this is to have nested method calls. And that is now discouraged because that would leak resources if errors occurred in the wrong place. So the preferred style is to declare separate variables for these, but now separate variables up until Java 10 required explicit type declarations. And so you end up with this certain amount of clutter here. But now look what happens when we substitute var for those. So the explicit types, as we've discussed before, are not adding anything to these, because you can look on the right-hand side and tell exactly what's going on. We got an input stream, we wrapped an input stream reader around it, we got buffered reader wrapped around that. So we don't need the explicit types anymore. So if we write var, it gets those explicit type declarations out of the way. It lets us join up the lines so that the resources all appear one line each. And we can see, okay, so let's look at the variable names. They all line up nicely. So I can see exactly where they are. So that's, I think that's a notable improvement in the code based on using var. So another example that came up is when you declare, suppose you're a library writer. Suppose you declare a class and you want people to use it. Choosing a good name might mean supplying some additional detail in a longer name, but then that penalizes everybody who uses it because they have to write that name all the time. So an example that I discussed with one of my colleagues, he had a provider class. And so the easy thing to do is to say, oh, I'm going to call this a provider. And so when one of his clients wants to use it, he says provider equals new provider. Okay, that's kind of typical. But the problem is that provider is really not explicit at all. What is it providing? And so if, in fact, there's this issue, which is if he has multiple providers, you might need to be more specific about what provider he wants. So in this case, what's being provided is a service, which is the hosting of a repository. So let's have a longer, more explicit type name, repository hosting provider. So that's a good name because it, in the context of this application or this library, it tells you exactly what's going on. But now you've penalized all your clients because they have to say, repository hosting provider equals new repository hosting provider, right? So there's a lot of redundancy here, and it's made worse because there's a long descriptive type name. But with var, you don't have that penalty anymore. You can say, okay, I'm in a section of code that deals with repository hosting. So I'm just going to say var provider equals new repository hosting provider. And that's nice and neat, and we don't have that redundancy anymore. Here's another example with generic types. And so again, if you're a library author, you might end up having to use types that use wildcards. And wildcards are, generics are complicated and wildcards make them more complicated. But it's a fact that when you need to use them in Java, you need to use them, and things can get very verbose. And so this is an example where we basically want to take a map and modify it. And the map has wildcarded type variables. And since we want to modify the map, we want to iterate over the entries of the map, but we want to modify the map. So instead of using the for each loop, we are forced to use an explicit iterator, which means that prior to Java 10, we would have to declare an explicit for loop variable of type iterator. And then also, when we want to get the next entry, we have to have an explicit type for that as well. And so, if you've ever written this kind of code, it's like, it's just really painful to deal with. And it's I don't know about you, but this is painful for me to look at on the screen. In particular, if you look at the header of the for loop, where are the different pieces, right? Where's the loop variable? What's the type of the loop variable, and where is the loop variable being initialized? All right, so I will highlight that for you. That is the declaration and initialization of the for loop variable. That is just the first part of the for loop header. And so that whole thing on the first, the first line of orange is the type declaration. And yes, you need to use the extra question extends map.entry because of the way wildcards work. And so that declares a variable named iterator and initializes it to the iterator of the entry set. And so notice that getting the iterator, well, if you deal with collections a lot, getting the iterator of a map's entry set is kind of obvious, but it's completely overwhelmed by the type declaration. All right, now where's the next part of the loop? The loop, the termination condition is there. It just, it just has next, and so that's buried way off to the side. And there's and the increment occurs within the loop body. You can see where next is called there, but again, it's completely overwhelmed by the need to have an explicit type declaration for the entry local variable. So now what happens if we use var? So we just use var in two places. One is where we declare the iterator, and it gets rid of that long, nasty generic type declaration. And then we can also use it for the entry in the loop body. And so that cleans up this loop nicely. And it's much easier to read what's going on. And I think, fairly importantly, the header of the for loop now fits on one line, which is, I think, what you want in general. So really, the explicit type is if you look at the explicit type in this slide, it is hurting a lot, because fundamentally what this does is it iterates over the entries of a map. Do you care about the exact type of the iterator? Do you care about the exact type of the map.entry? No, you know that it has something to do with a string and number, and you iterate over entries of string and number. And this is all quite clear from the context. And so using var here is a great improvement in getting rid of these redundant type declarations. Okay, so let's move on from from that topic. One of the things that you hear a lot about in Java is this concept of programming to the interface. And I think that's a good concept, but var does have some, it does cause some wrinkles when you use var. All right, so let's look at this first line here. So here we declare a list of string called names, and we initialize it to an array list from some initial set of names. Okay. Now, if we replace the explicit type with var instead of list of string, this works, and this works fine, probably. But there's a subtle difference here. So the names variable is now inferred from what's on the right-hand side. And the right-hand side is array list of string and not list of string. And that's different from the first line of code above. And so some people will object to this, because you should always program, they claim that there's this rule, you should always program to the interface. And there's something to this. I think that programming to the interface is a good principle. But I also claim that in many cases, this doesn't make a difference for local variables. So let's look at an example here. So here we have a method, getNames. It takes some initial names and returns a list after modifying it. So we say list of string names equals new array list. And then we add some things to it based on some logic, and then we return the names. All right, so this local variable names has an explicit type list of string. Now let's change this to var. So the names variable is now array list of string. And we're using some logic to add things to it, and then we're returning names. Does this make a material difference that we've changed the declaration from list of string to array list of string? No, because this change only occurs within the method. Now, this idea of programming to the interface is still important, because the return type of this method is declared to be list of string. Now, this is where programming to the interface is important. You might want to change the you might want to change the implementation type to be something else within this method. But as far as your callers are concerned, you want them to only know that it is a list of string. And that's why we have explicit type declarations on the return type of methods. But changing a local variable to use var and thereby changing its type subtly really does not make a difference in most cases. Now, you might argue that if you have a 100-line method, then this kind of stuff can go on in here. But maybe that also means that your method is too long. So, but if you have a short method, I wouldn't worry too much about using interfaces versus implementation types in local variables. It just isn't that big of a deal in most cases. Where it is a big deal is with APIs. And so that's when programming to the interface is still a very valid and useful concept. And again, so I'm referred to the explicit declaration of the method return type. Var cannot be used there. And again, this is one of the reasons. All right. Let's move on. OK, there are some cases where you do need to take some care with using var if the initializer has the diamond operator in it or if it's a generic method. And so again, the type is inferred from what's on the right-hand side. Now, diamond is kind of a weird case because if you have, yeah, I have some examples on the right on the next slide. But let me talk about it for a moment and then show the examples. So if you use diamond, then that also uses type inference. And if that is occurring on the right-hand side, and if you use var on the left-hand side, then you have type inference going on both sides. And isn't that a problem? For lambda, like in a previous example I showed, that's so much of a problem that that's an error. For diamond, it's not an error, but it's probably going to do the wrong thing. So let's look at these examples here. So we have 4 examples using an explicit type declaration versus var and using the diamond operator with, now in this case, the diamond operator can also, okay, so let's look at V1 here, sorry. What does the diamond operator do? It needs to infer the type of the array list. And it can get this information from the left-hand side, or it can get it from its method argument. So initial names we know is a list of string. And so diamond says, okay, so since I'm being initialized from a list of string, I know the type argument for array list also needs to be string. So we have 2 examples here with a constructor argument, initial names, and then 2 examples without an argument. And so the variable v1, this is pretty clear. This is kind of conventional Java code. With variable v2, we're using var here. And so this is the case, like I just talked about, where the type of v2 is inferred to be array list of string. Okay, and so that works fine for most cases. Now v3 is fairly conventional Java code, at least since Java 7. We're declaring a list of string and using the array list constructor with no arguments and using diamond. And so for this case, diamond needs to look on the left-hand side to find out what its type argument is. And so that's where it gets string from. And so case 4 is the problematic one, where you have not enough information on the right-hand side, and you also don't have any type information on the left-hand side. And so you might think, well, if we have type inference going on both sides, why isn't this an error? And this is actually a really good question. Historically, if the diamond operator didn't have enough information to infer a type, it would infer object. And so for compatibility reasons, we are still inferring object. And so what will happen is that v4 will get a type inferred of array list of object. And this is probably not what you want, because you're going to be, the assumption is if you create a new array list, you're going to be adding things to it, and you're probably not going to be adding objects. You're probably going to be adding something else. So this is quite probably wrong. But as I said earlier, for compatibility reasons, Diamond will infer object here, and so this statement is legal. Now, but since it is problematic, we are considering adding a compiler warning for this case, because it is probably doing the wrong thing. Meanwhile, what you should do is avoid cases where you're using var on the left-hand side and you're using Diamond or generic method on the right-hand side when there's not enough information to determine what the type is. And so that information often comes from method arguments like initial names. And so in those cases, it's okay. But if you have no arguments, then that's something to look out for, where you might not have enough type information on the right-hand side. All right, let me run over to a quick demo here. So this is NetBeans 9, which has support for Java 10. Because of the this is Apache NetBeans, and so the versioning is kind of off. So oddly enough, NetBeans 9 does have support for Java 10. And so I pulled a simple example off of the web and modified it a little bit. But basically, this is a simple example of using, of doing JSON processing. And I'm just using, so the JSON here, the application is not interesting at all. Just read some JSON and then modify some objects. But what I wanted to do is use this to show an example of where var can be used in, and I think more realistic example. So let's run through this pretty quick. So we can't use var for method parameters. We can't use var in this case because there's no initializer. So we type var there, but that should give us an error. I don't know why it's not giving us. Oh, okay. So there's an. I don't know if you caught it to the bottom of the screen. There was an error message at the bottom of the screen.
No, I think we didn't. Well, can you check again? Okay.
Yeah, I was expecting to see a red squiggle there, and I didn't. But anyway.
Okay.
But anyway, it is definitely illegal to use var here. However, we can use var here and here. Notice. So we're having a try with resources statement here. Company equals new company. We can use it here. Where's some more declarations? JSON array equals. Okay, so here, let's see. Does this explicit type can be replaced with var? Why isn't this? All right. Well, there is a feature in NetBeans. For some reason, it is not working for me right now, where you can pop up a menu and replace the type with have NetBeans do a refactoring for you and replace it with var. And you can also have it do the inverse, and it is not working out for me. So sorry about that. Convert var to explicit type. Why doesn't?
No worry. It's always like that. You
Right.
probably forgot to sacrifice something to the demo god.
Yeah. Yep. Oh well. But trust me, there's and this is not unique to NetBeans. I think the other IDEs, I know for sure IntelliJ has a similar thing. Anyway, so you can do some refactorings to go in both directions. I think that's the main point, which is it's easy to select a type and replace it with var. But in this case, notice this is not a JSON object, it's a string array. And we can use it here because we have an explicit type on the right-hand side. I think there's this question though, should we use it? Because and that's a good question. I think that's a question that you need to ask yourself when you're using var. Some people want to use var everywhere. I'm not sure I would recommend that. I would recommend using it when the type that you're replacing does not add any value, right? So we have JSON value. And I think the JSON example is interesting because the JSON types like JSON object, JSON value, and so forth, those types don't have any meaning to your application. But string array, I mean, that's some application data. So maybe that's a case where maybe this is a case where you want to have an explicit type, but this is a case where you just want to use var because you're just iterating over the value of a JSON array. So you're not losing anything by getting rid of the explicit type here. JSON object is another case. I can type var here instead. But address, well, that's application data. So maybe I should leave that as an explicit type, or since the variable name is address, maybe I don't need the explicit type there. Since I have address on this line 3 times, maybe it makes sense to use var there as well. And so the point here is not to replace everything with var. The point is to say, oh, OK, let's use var when the explicit type is not providing any value to the readability of the program. And what's interesting here is that since I got rid of the explicit type declarations of several of the JSON types, then a bunch of my imports, you can see, if you look carefully, there's some gray squiggles here. And this is NetBeans telling us that these imports are no longer used. And so I can just hit a key combination to say clean up imports, and my imports get a little nicer. And that's not a big deal, but notice, the program got a little shorter overall and a little cleaner overall through the use of var. All right.
Wonderful.
Slides and a quick recap. Was there something there, Roberto? Question?
No, yeah, that was wonderful.
Okay.
I mean, I really enjoyed the sample that you show over there. I think that's very detailed, and it's probably one where people are going to see the most value of using var on their applications.
Right. All right, so a quick summary here. So var tells the compiler to infer the variable's type for you. Java is still statically typed. And this is the key. If var is used judiciously, it can improve readability and clarity and reduce clutter and verbosity. I don't recommend using it in all cases. And so there's some documents about when to use it, in particular the style guides. And I will move to the next slide here. And actually, people could probably screenshot this and if they read the links off the QR codes.
Oh yeah, let me try.
There are 2 documents here. One is the style guide, which I referred to earlier. Another one is the FAQ, which does cover, I think, a number of actually frequently asked questions and provides answers to them. And this is the JEP, the JDK enhancement proposal link here, which I don't have a QR code for, but that's the original proposal if you want to go back and look at that and look at the nitty-gritty details. And there's my Twitter handle and the hashtag. And so I can just leave this up here for a while. Yeah. Are there any, and I can switch over, well, let's see, I'm still sharing the screen. So I'll just leave this up for a while. And Roberto, can you check Slack for me to see if there are any?
Of course. We had a couple of questions over there. Actually, so one of the questions, and I actually waited because I knew that you're going to answer that during the presentation, was about the custom interface. So when you're using coding to interfaces, and what's the actual infer type when you're using var. But you answered that already over that. So basically, that's the case where you have, for instance, customer service and customer service imp, and the ones that get inferred by var is actually going to be customer service imp, right?
Right.
And then we have here another question, which I believe that should work the same way, but we have Stefan asking, so is there any change when you're using var with instance off? So it should also infer for the same type, and it should also work the same way, right?
Well, it works the same way, except that the type is inferred instead of. Oh no, excuse me. That's right. Instance of checks the runtime type.
Mm-hmm.
So in fact, yeah, there should be no change at all. Although maybe somebody could come up with some contrivance where, because there are some cases where instance of is so the compiler will statically check instance of, but it will only be an error if what you're checking instance of cannot possibly be true. So if you say, if you have a string variable and you say if instance of integer, I think that's actually a compile time error, because it knows that there is no way that a string can be an integer. But there are some surprising cases with interfaces. But so somebody might be able to come up with some corner cases where there's a change in behavior. But since instance of checks the runtime type of things, and var only affects the static type, then I do not believe there is any change to instance of.
Okay. Okay, some people are actually posting your slides and the QR codes. I think that's an awesome idea, actually.
Okay.
Yeah. So actually, I don't think we have any more questions here right now, but I think you can join us on Slack, and people can talk to you for a while if you want. Anyway, we actually run out of time, so.
Oh yeah, we're at the top of the hour. Okay, I guess I talked slow this time.
No, I mean that was great. I mean, thank you so much for this wonderful presentation. As I say before, I believe it was the first one that we actually had dedicated fully to var on the VJug. So I think this will be a wonderful resource for our audience to actually grab and have when they're looking for this kind of information. So thank you so much for joining us and bring us this awesome session.
Okay. Well, I'm glad to be here, and thanks for having me on.
Yeah, I mean, anytime, and they'll definitely would like to have you here soonish enough when you come up with the newest, greatest thing in the Java world, as you know. So at some point in the presentation, Stuart mentioned that Nikolai is going to give a session on var as well. So if you allow me, I'm going to promote that a little bit. So December 12th, we're going to have another session around var, and that's going to be called Fun with var in Java 11. And that's going to be with Nikolai. And basically, it's going to pick up all these var concepts and going to apply them in a more advanced ways. So let's see what Nikolai can show us. So other than that, sign up for that session if you want to learn more things about var. And of course, Stuart, you're invited to come if you like to join us in the panel. It's going to be at the same time. So
yeah, actually, that's a good point. So I have spoken to Nikolai about this. We're quite friendly. He's going to explore a bunch of the edge cases with var. And so I think one of the things about var is it looks like a really simple feature, but any language feature has a lot of edge cases. And so Nikolai's going to do an exploration of those. So yeah, actually, that's a good point. Maybe I should join it, because he's written some articles about it, and so I think I know what he's going to say, but I don't think I've actually seen his presentation. So I will try to join you for that one.
Yeah, that will be wonderful. So again, thank you so much for having us, and thank you so much for the audience to be here with us. So until next time, see ya.
Okay. Bye-bye, everyone.
Bye-bye. Bye-bye.